Hey guys, how are you? This is Dr. Mahabd Rahman and another video about covalent bonding. I'm starting my class with this diagram about diamond and graphite. Why I'm choosing diamond and graphite? Because as you see, the properties of each is completely different. We know diamond is shiny, expensive, very hard, while graphite is dull and brittle. Surprisingly, both of them, diamond and graphite, are made up of carbon atoms. So both are made up of carbon atoms with completely different properties. The reason behind this is the way the carbon atoms bonds. So the reason is the way how carbon atoms bond in each compound is different. So that was an introduction to what I'm trying to introduce today. The type of bonding between or within diamond and within graphite is a type of bonding very common of chemistry called covalent bonding. Covalent bonding. Covalent bonding, what's the difference between covalent bonding and ionic bonding? That's what we're gonna know today in this presentation. So covalent bonding versus ionic. Check back my previous videos for ionic bonding. Ionic bonding involves complete transfer of electrons from one atom to another. So in ionic bonding, you see there is a complete transfer, as I said, from electrons. You can check my previous videos regarding ionic bonding. So there's a complete transfer of electrons from one atom, which is usually will form the cation, to the other atom, which usually will form the anion. For more details, go back to my previous video. Today, my focus would be on covalent bonding. See, that's a model of two atoms over there. These two atoms are sharing electrons. If you check, guys, these 4 electrons here are shared between the two atoms. Of course, the shared electrons are electrons in the outer shells, okay? So only the outer shells electrons, atoms are able to share. When I'm talking about sharing electrons, I mean that none of the electrons are completely lost nor completely gained. These 4 electrons are shared, meaning they're actually positioned between both atoms, the first atom and the second atom. Okay, so it's under position of both atoms together. These are the shared electrons. So electrons are neither lost nor gained. Okay, it's actually shared, as if these two atoms are holding hands. Okay, now I want to also highlight important part, which is why do you think atoms would share electrons to reach its ultimate goal, which is becoming stable? That's the ultimate goal for all atoms, to become stable. How would atoms become stable? When they have a full outer shell. So when they have a full outer shell, atoms are stable, okay? To have a full outer shell, most of the atoms would require 8 electrons, okay? So 8 electrons in the outer shell. Let's go ahead and count. So there's a 1, 2, 3, 4, 5, 6, 7, 8, and I'm only talking about outer shell. 1, 2, 3, 4, 5, 6, 7, 8 for the other atom. So both atoms are stable. This atom is stable. The other atom as well is stable, having 8 electrons in the outer shell. And that's the purpose of atoms forming covalent bonding, to become stable, having a full outer shell. A question let me arise here. What stabilizes these shared electrons between the two atoms? What stabilizes these electrons between the two atoms? Well, actually, please note that the charge in the nucleus of each atom is positive. I think that's an information that most of you knows. So the nucleus charge is positive. Electron charges are negative. So having negative charge electrons in between two positive nuclei, according to physics, they would attract one another, okay? So we know that negative and positive attracts. So that's the reason, because of the attraction between the electrons, the shared electrons, and the positive ion, that's why these electrons are here in place. With that being said, I would expect that covalent bond is a strong bond. Covalent bond is a strong bond. Why? Because this electrostatic attraction between the negative shared electrons and the two positive nuclei is a strong attraction. That's why covalent bond is a very strong bond. To highlight what I just said, here we go. Covalent bonding is about sharing electrons. This usually happens between the nonmetals. So usually covalent bond, guys, happen or actually occur between or when two nonmetals are bonding together. So this happens between two nonmetals, okay? It could happen within the same nonmetal, like for example, if an oxygen atom is bonding with another oxygen atom, that's a covalent bond as well. Chlorine with chlorine, that's a covalent bond. So two nonmetals could be the same within the same nonmetal, or two different nonmetals, like for example, hydrogen and chloride. That's also a covalent bond, okay? So they share pairs of electrons to make up covalent bonds. The positively charged nuclei of the bonded atoms are attracted to the shared pair of electrons by electrostatic attraction, which makes it very strong. So I'm just echo what I've said again. Atoms only share electrons in their outer shells, and each covalent bond provides one extra shared electron for each atom. This covalent bond is strong. You can see it in within the same nonmetal, as I said, like chlorine, or a compound of two different nonmetals like water. So if you check water, oxygen atom is bonded covalently to a hydrogen, and then there is another covalent bond to the other hydrogen. And I'm going to go over the dot and cross diagram for different shapes of molecules like water, methane, etc. in my upcoming video. So for this video, again, quickly, they're showing you the diagram, the covalent bonding here between nitrogen and the three of the hydrogen atom. Here you can see the two shared electrons. So that's a one covalent bond, two, and then three. That's what's called dot and cross diagram, okay? And as I said, that's not the focus of my presentation today, but I'll give it an other separate presentation to explain all the dot and cross diagram, how to draw it, and how to present it in many other compounds. So my main focus today is the difference in structure between diamond, graphite, and silicon dioxide, which is a main, essential, common question that usually comes in all school boards. Cambridge, Edexcel, Oxford AQA, and AQA GCSE. That's a common question, all right? Which is the difference between diamond, graphite, and silicon dioxide. I'm gonna start, guys, with the difference in the structure, and then I'm gonna link that to the properties, okay? Because when the structure is different, hence the properties will differ as well. So let's check together the structure of the diamond. Here you see each sphere, guys, represents a one carbon atom. So as you see, each carbon atom is bonded to 4 other carbon atoms. Each carbon atom is bonded to 4 other carbon atoms with a strong covalent bonds. So each carbon here forms 4 covalent bonds. This structure, guys, is called tetrahedral. Tetrahedral, just like pyramid, okay? Because of this, you would expect diamond to be very hard. Very hard because you require a lot of energy to break all of these multiple covalent bonds between the carbon atoms. And I already mentioned covalent bond is very, very strong. So it requires a lot of energy to break these bonds. That's why diamond is hard. Do you expect diamond accordingly would have a high or low melting point? Oh, bonds are hard, bonds are strong. It would have a high melting point. Common sense. All right? So hard, high melting point. Finally, for diamond, do you expect diamond would conduct electricity or no? For something to conduct electricity, you require a movable charge. This movable charge could be an electron, could be an ion, all right? Could be an electron, could be an ion. In this case, where you see carbon atoms are covalently bonded, I don't see any ions, and I don't see any free electrons. So that's why, again, common sense, diamond is won't conduct electricity. So it won't conduct electricity. Okay, it won't conduct electricity. Guys, that's what's stated here. So you really don't need to memorize or learn that again, because that's already common sense, already goes without saying. If you understand the structure, you will get why diamond is hard, because diamond has a giant covalent structure. Guys, giant covalent structure, we call this structure because it's very big, having a lot of covalent bonds, so we call it giant covalent structure, where each carbon atom forms 4 covalent bonds. This makes the diamond really, really hard. Strong covalent bonds requires a lot of energy to break, so there's a high melting point as well, okay? So it doesn't conduct electricity because there's no free electrons. So all of this is common sense for me if you already understood the structure. That's it for diamond. Let's move up to graphite. Before I move up to graphite, I want to give a hint about silicon dioxide, because this structure, guys, is very similar to diamond. So am I expecting strong covalent bonds as well? 4 strong covalent bonds? Yes. As you see, each silicon here, guys, from the name silicon dioxide, that means I'm expecting a silicon and an oxygen. See, the silicon atom is the black one. The oxygen are the red. So from the structure, we can see that each silicon is bonded to 4 oxygen atoms. As I see, each silicon is bonded to 4 oxygen atoms. All right? Again, do you expect that structure to be hard or soft? Hard, definitely. 4 strong covalent bonds, right? High or low melting point? High. High melting point, just like diamond. Because there are many strong covalent bonds that requires a lot of energy to break. Conducts electricity or no? No conduction. No conduction of electricity. Okay? So very, very similar to diamond. Now let's move to graphite. They love to ask about the graphite. Graphite structure, guys, is different. So if you check for graphite structure, have a look, please. You see here, we agreed each sphere is a carbon atom. So if you trace up one carbon atom, it's bonded to three other carbon atoms. So each carbon is bonded to three other, just guys follow up one of them. Okay, you see it's, so if you trace up one, it's bonded to three other carbon. Let's check this one, also bonded to three other carbon. So each carbon is covalently bonded to three other carbon. So three covalent bond for each carbon. Now, in a previous classes, I'm gonna maybe download that also, guys, soon, regarding relating the group number on the periodic table to the number of the electrons in the outer shell. Okay, but for now, carbon is in group 4. Carbon is in group 4. Okay, meaning if it's in group 4, meaning carbon has 4 electrons in the outer shell. Okay, since carbon has 4 electrons in the outer shell, the maximum number of covalent bonds carbon can form is 4 bonds, because each electron can form a 1 covalent bond. That's the maximum number. But what we see here in the graphite, that each carbon is bonded only to 3 other carbons, right? So is only bonded to 3 other carbons. That means, that's what we see here in the structure, right? Each carbon is bonded to 3 other carbons covalently. That means this electron, this 4th electron, is free. Free electron. Okay? It's not bonded. It's not a bonded electron. It's a free electron. So that's why we see in the structure of the graphite, there are layers of hexagon. Why hexagon? Why hexagon, doctor? Why? Because each carbon atom is bonded to 3 other carbons, so this will form a hexagon layers, as you see. And there are delocalized electrons, free electrons within this structure. There are free electrons. This free electron is a movable electron. It's free to move, all right? So this free electron is free to move. That's why, do you expect graphite to conduct electricity or no? Remember what did I say? I just said, guys, if the electron is free to move, then electricity can be conducted. So this one can conduct electricity because of the free electrons for each carbon. Please don't forget to mention there is a free electron for each carbon. Don't forget this model. There is a free electron for each carbon. All right? That's what's, there's another property, okay, for graphite. So another property, which is that graphite is soft and slippery. Again, this is already represented in the structure, okay? Because the structure of the graphite, each carbon atom only forms 3 covalent bonds. Okay, so this will form a sheet of hexagons. And please look at the bonds between the sheets. These are very free bonds, okay? So these bonds aren't bonded covalently. Why, guys, these sheets aren't bonded covalently? Because there isn't any covalent bond you see between the layers. The covalent bond is only within the layer. Right? So there are free forces between the layers, all right? So there, these free forces, or these weak forces between the layers, these weak forces allows the layers to slide over one another, so slide over each other. Okay? Makes the graphite soft and slippery. By the way, guys, graphite is used to make pencils. Oh, that's why when we write using pencils, it slides over the paper. Yes, that's exactly why. So as you see, chemistry helps you to build models, understand things, why pencil has the property it has, why diamond has the property it has, and that's actually the purpose of learning chemistry, right? To understand things, to get things rather than just memorize abstract information. So that's why graphite is soft and slippery, because it's made up of layers of hexagons. The forces between these layers is very weak, so the layers can slide over each other. Okay? Regarding the melting point, it's still high. It's not as high as diamond, but it's still high. Why? Because you still have loads of covalent bonds. See, guys, all of these are covalent bonds within each layer that requires. So all of these are covalent bonds. So you have loads, a lot. Okay, you have a lot of covalent bonds as well within the graphite that requires a lot of energy, right, to break. Now, and as I mentioned finally regarding the properties of graphite, it can conduct electricity and thermal energy due to the presence of free moving electrons. Why, guys? There's a free moving electrons in graphite. There's always Y and Y and Y in chemistry. So why? Because each carbon is bonded to 3 other carbons. And remember we said that carbon meant to have 4 electrons in its outer shell. It's only bonded. Only 3 of them are bonded. The 4th electron is free for each carbon. So that's why graphite can conduct electricity. Okay, that's why graphite can conduct electricity. So that was a common part in the IGCSE school boards about the difference between diamond, graphite, and silicon oxide. Most important thing, guys, don't please memorize notes without understanding. Don't sit down and just learn and memorize characteristics of diamond or graphite without you understand things, because questions are more application questions that requires you to understand the knowledge rather than just memorizing. I'm highlighting this every class because we see recently that question styles has changed to become more application question, inferring questions, relating information rather than just memorizing notes. I hope the video was beneficial for everyone. See you guys next year. Looking forward to meet everyone. Thank you so much.